So now that we've looked at the basic strategy for how to approach these problems, let's look at a couple more examples. So in this one, we've got this polynomial p of x, which is again a cubic, and it also has a known factor of x plus 3. So this linear factor, x plus 3, would divide evenly into this polynomial. So if we actually carry out the long division, we should be able to find the other factors here. And since it's a cubic, we should have 3 linear factors in the end. So we're going to take our x cubed plus 7x squared minus 36, and we're going to divide it by x plus 3. And we should end up with some quadratic polynomial. And once we get that quadratic polynomial, we will further factor that so that we will have our 3 linear factors. So to carry out this division, we're going to use long division. So we have x plus 3. We're dividing by that, so it goes on the outside. And on the inside, we have x to the third plus 7x squared. And notice we do not have an x term. So as a placeholder, we have to put 0x here. If you forget this, it's going to cause a lot of confusion when you actually try to do the long division. So make sure to put in any of those missing terms. Now, to carry out the long division, we ask, what do we multiply x by to get x to the third? Multiply by x squared. And then we multiply x squared by this linear expression here to get our remainder. So x squared times x, that's x cubed. X squared times 3 is 3x squared. We subtract to find a remainder. The first two terms should always cancel out. So that's 0x cubed. And we have 7x squared minus 3x squared, which is 4x squared. And then we bring down our next term. So that's 0x, that's our placeholder. And we repeat the process. So what do we multiply x by to get 4x squared? Well, we multiply by 4x. Now we multiply 4x by our linear expression here that we're dividing by. So we get 4x squared. 4x times 3 is 12x. Now we subtract. We find our remainder. Let me just make some more room here. And when we carry out the subtraction, the first terms go away, and we do 0x minus 12x, which is negative 12x. We bring down our constant term, so that's the minus 36, and we repeat one more time. So x times negative 12 will give you negative 12x, so that's what we have to multiply by, and we will multiply that by our linear expression here to get our remainder. So you get minus 12x, and minus 12 times 3 would be minus 36. Notice you end up with the exact same thing, and we're going to subtract here. So our remainder should be 0. Minus 12x minus negative 12x, or plus 12x, is 0. Minus 36 minus negative 36. Again, we're going to be adding 36 to negative 36, and that's 0. So our remainder is 0, which is what we're looking for. That's our way to check that we're doing this right. And so this x squared plus 4x minus 12 would be our final answer when we carry out the division. So let me just summarize what we have so far. We have that our given polynomial x cubed plus 7x squared minus 36 is really equal to x plus 3 multiplied by this quadratic, x squared plus 4x minus 12. And you could, of course, re-multiply this out just to double check that you're doing everything correctly. But at this point, we need to further factor this x squared plus 4x minus 12. And since the coefficient on x squared is 1, we can use the slightly faster method, essentially the reverse of foiling it out. So let me just put our 2 missing binomials that we're looking for, our 2 linear factors here. And we know that each of these will have 2 terms. And the advantage of the coefficient on x squared being 1 is that this term and this term both have to be x. That's the only way to get x squared. Now our number terms here, these are both going to be constants, numbers. They're going to multiply to negative 12, and they're also going to add to positive 4. So we can write out our list, what numbers multiply to negative 12, and then from that list we'll ask which of those add to 4. So we can do minus 1 and 12, 1 and minus 12, we can do 2 and minus 6, minus 2 and 6, and so on, but we've already found what we're looking for, so we can stop. because minus 2 and 6 add up to 4. So this would be minus 2. This would be positive 6. And of course, you can check this. Just redistribute, multiply it out. You get x squared plus 6x minus 2x and minus 12, which is, in fact, what we started with. So we found out that our polynomial, oops, let me go back to that. We found out that our polynomial, our p of x here, this whole thing is p of x, can be factored into these 3 linear terms. So our final answer that you would put into the box would be x plus 3 times x minus 2 times x plus 6. So in summary, the majority of the work in this problem is carrying out the long division and then factoring your resulting polynomial, which is, in most cases, a quadratic. And there are a lot of advantages to this, which we will look at after finishing the last problem.